Hello, welcome to Digital Urim. In the previous video, we learned about processes, services, and scheduled tasks in Linux. We saw that an analyst must know how to answer questions like, what is running? Who is running it? With what privileges is it running? Is it a normal process, a system service, or a scheduled task? Today, we are taking the next step, because knowing what is running is important, but it is not enough. We also need to know what happened on the system, and for that, we use logs. In an earlier lesson of this course, we talked about logs, events, and alerts as a general cybersecurity concept. But in this video, we are going into the practical side, inside Linux. Today, you will learn how to review system logs using tools like journalctl, files inside /var/log, and commands like less, tail, and grep. A log is a record of activity. In Linux, logs can store information about logins, failed authentication attempts, sudo usage, services starting or failing, system errors, kernel activity, scheduled tasks, important changes inside the system. From a cybersecurity perspective, logs are evidence. But there is something very important. A log does not always mean an attack. A log is a clue. The analyst's job is to interpret that clue within context. For example, one failed login attempt may be normal, but 500 failed attempts from the same IP in a few minutes may indicate a brute force attack. A sudo event may be normal, but sudo usage outside normal hours by an unexpected user may require investigation. The value is not only in reading the log, the value is in understanding what it means. In most Linux distributions, traditional logs are stored in the directory /var/log. We can list its content with ls-lah/var/log. Inside that directory, you may find plain-text log files such as auth.log, syslog, kern.log, secure, messages, but names change depending on the operating system family. On Debian, Ubuntu, or Kali-based systems, it is common to see /var/log/auth.log, /var/log/syslog. On Red Hat family systems, such as CentOS, Fedora, Rocky Linux, or Alma Linux, it is common to see /var/log/secure, /var/log/messages. This is vital for your career. Not every Linux system organizes logs exactly the same way. As an analyst, you do not memorize only one path. You learn the concept and then validate how that distribution stores its records. Later, you may also find kernel information using commands like dmssg, but for this lesson, we will focus on traditional logs and journalctl. To read a log file, we can use less/var/log/auth.log. Less allows you to navigate the file without loading everything at once. We can also view the last lines with tail/log/auth.log. And if we want to follow new events in real time, tail-f/log/auth.log. We can also search for specific words with grep. For example, grep failed password/log/auth.log. This command searches for failed password attempts. But here is a professional trick. If we add the -i option, grep no longer cares whether the word is uppercase or lowercase. For example, grep-i failed/log/auth.log. This can find variations such as failed with the first letter capitalized, failed, all lowercase, failed, all uppercase. In real analysis, this helps because not every service writes messages with exactly the same format. We can also search for events related to sudo. grep-i sudo /log/auth.log. The goal here is not to memorize every command. The goal is to learn how to filter evidence. A large log file may contain thousands of lines. The analyst must know how to reduce noise and find important signals. Many modern distributions use systemd, and with systemd, we have a very important tool, journalctl. Journalctl allows us to query logs managed by systemd. But here is an important permission detail. If you try to review system logs or service logs as a normal user, you may receive a message like, "No journal files were opened due to insufficient permissions." This happens because reviewing system logs means reading activity that may belong to other users or critical services. That is why, in practice, we often need elevated privileges. To view recent system logs, we can use sudo journalctl-xe. To view logs from today, sudo journalctl-since today. To view logs from the last hour, sudo journalctl-since 1 hour ago. And if we want to review logs for a specific service, for example SSH, we can use sudo journalctl-u ssh-since 1 hour ago. Or, depending on the distribution, sudo journalctl-u sshd-since 1 hour ago. This connects directly with the previous video. Before, we saw how to check services with systemctl status SSH. Now we see how to review that service's activity with sudo journalctl-u ssh. A service tells you what is active. The log helps you understand what has happened. Here we learn an important lesson. To review system activity, you often need elevated privileges. In cybersecurity, even observing requires permissions. One of the most important types of logs for an analyst is authentication logs. These can show login attempts, successful logins, failed passwords, sudo usage, user switching, sessions opening or closing. On Debian, Ubuntu, or Kali systems, you can review /var/log/auth.log. On Red Hat, CentOS, Fedora, Rocky Linux, or Alma Linux systems, you can review /var/log/secure. An example search would be grep-i failed password /var/log/auth.log. This can show failed SSH access attempts. You can also search for successful accesses. grep-i accepted password /var/log/auth.log. Or grep-i accepted public key /var/log/auth.log. From a society perspective, these events are important because they can help detect brute force, unauthorized access, suspicious account usage, after-hours activity, possible credential compromise. Imagine this scenario. A company has a Linux server exposed to the internet for remote administration. During a review, the analyst runs grep-i failed password /var/log/auth.log and finds many failed attempts for users such as root, admin, test, user. This may indicate brute force attempts, but the analyst should not stop there. The analyst must ask, which IP address are the attempts coming from? Brief pause. How many attempts occurred? Brief pause. At what time? Brief pause. Was there a successful login afterward? Brief pause. Does the targeted user exist on the system? Brief pause. Does SSH allow root login? Brief pause. Are there MFA or additional controls? One line does not tell the whole story, but many related lines can show a pattern. That pattern is what the analyst must identify. Here, the student must understand something important. The analyst does not only execute commands. The analyst investigates. Sudo usage is also important. When a user runs commands with elevated privileges, that activity may be logged. We can search for sudo events with grep-i sudo /var/log/auth.log. A sudo event may be completely legitimate. for example, an administrator installing updates. But it may also be suspicious if it happens outside normal hours, it is executed by a user who does not usually administer the system. Sensitive commands are executed. It appears after many failed attempts. It happens right after an unexpected login. Here we see the professional mindset again. The command is not enough. Context matters. Logs also help us review services. For example, if SSH is restarting, failing, or receiving many connection attempts, we can review sudo journalctl-u SSH, or depending on the distribution, sudo journalctl-u SSHD. If we want to limit the time, sudo journalctl-u SSH -since today. We can also review other services. For example, for cron, sudo journalctl-u cron, or in some distributions, sudo journalctl-u cron-d. This connects with scheduled tasks from the previous video. If a script runs automatically, it may leave traces in logs. An analyst must connect process, service, scheduled task, user, privilege, log. That connection turns separate data points into an investigation. A common mistake is thinking that reading logs means finding a word like hacked or attack. In the real world, logs do not always speak that clearly. Many times you will see authentication errors, restarted processes, opened sessions, executed commands, rejected connections, services failing, user switching. The analyst must interpret. Another common mistake is reviewing only one line. In an investigation, one line is rarely enough. You need to look for sequence. First, this happened. Then that happened. Then this event appeared. Finally, this user executed this command. That sequence builds the story of the incident. That is why logs are not just text. They are pieces of a timeline. There is also another risk, not having enough logs. If a system does not record important events, the company loses visibility. Without logs, it becomes harder to answer questions like, who logged in? When did access occur? Which service failed? Which command was executed? What happened before the incident? We also need to consider log rotation. Linux can compress, archive, or rotate old logs to save space and prevent files from growing without control. This is normally handled by a tool called logrotate. Logrotate allows administrators to define when a log is rotated, how many old copies are kept, whether they are compressed, and when they are deleted. This is normal and necessary. But from a cybersecurity perspective, it also has an impact. If the organization does not keep logs long enough, it may lose important evidence during an investigation. That is why, in professional environments, logs are often sent to central systems, like a SIEM, where they can be analyzed, correlated, and retained for a longer period of time. Today you learned how to review Linux system logs. We covered what system logs are, where they are located in /bar/log, differences between Debian, Ubuntu, Kali, Red Hat, CentOS, Fedora, and Rocky Linux, how to use less, tail, and grep, how to use grep-i for case-insensitive searches, how to use sudo journalctl, how to review service logs, how to analyze authentication events, how to interpret failed attempts, successful logins, and sudo usage. Why logs are evidence for an analyst. The role of logrotate. Remember, a log is not a conclusion. A log is a clue. The analyst's job is to connect clues, understand context, and make decisions based on evidence. In the next video, we will study package management, updates, and patching in Linux. You will learn why keeping a system updated is not only an administrative task, but an essential security practice. Understand, defend yourself, grow.